giving you a 10-minute or so overview of the progress CISQ has made recently in creating standard automatable metrics for software quality and for software size. And then after that, we'll have a longer session where Jasmine will discuss some of the issues that she has had in using these kinds of measures and other quality techniques in the media industry. So let's start with an update on where CISQ is. CISQ was formed several years ago by the combination of the Software Engineering Institute at Carnegie Mellon and the Object Management Group in order to be able to pull together industry resources for defining common measures of software attributes, software quality attributes, and software size attributes. And our objective was to engage both IT executives in prioritizing what measures they felt the industry needed, and then having their technical folks come together under the OMG umbrella and using the OMG standards process to actually produce these standards. So SEI's contribution is that it's a very neutral ground where we found industry can come together and discuss major issues facing the software world. And so as they formed this consortium, we had 24 companies join, and you see these very large companies and some very small companies. We had a number of large IT shops like McKesson in the healthcare industry and UBS in the banking industry and Alcatel-Lucent in the telecom industry. We had large system integrators like IBM and Capgemini and Tata, Infotech, and a number of others. And then we had small companies that provide products and services into this market like the David Consulting Group and our company CAST and OutSystems Group and a number of others. So it was a combination of large IT organizations, of system integrators and outsourcers, and of people that provide technology and services into this space. And the objective, the original objective, was to create standard automatable measures, and we had forums where IT executives basically voted on the measures they felt most important for managing cost and risk in their environment. And the 5 measures they asked us to undertake were, number one, in the size area, they wanted us to undertake automating function points as defined by the International Function Point User Group. So that was one of our efforts in the size area, and then there were 4 quality metrics that they defined. They wanted us to produce automatable measures or standards for automatable measures of maintainability, reliability, performance efficiency, and security, and then recommend methods for how they could use these in practice. And so we began work. We started pulling technical groups together of representatives from these 24 different companies to work on defining what these measures would look like. I'm going to show you the progress and the kinds of results they're getting in a second. And then they go through OMG's standards process, which we're working through right now. And these create various measures that are built on OMG's various meta models. So there's a formal definition underlying them, and then once they're standardized with OMG and become supported specifications, then we can use OMG's fast track over to the various relevant ISO standards that these metrics might fit into. So that was the process as originally envisioned. Now, where are we today? We have 2 standards that have been produced to date. The first one is undergoing its final stages with OMG, and that's automated function points. According to the guidelines defined by the International Function Point User Group. But the difference here is that there's a lot of ambiguity left in the formal guidelines so that function point counters can make decisions based on the intent of the designer and a number of other kinds of issues. So it can be differences between the function point counts of different manual counters. Plus, it's very expensive to count them manually. In order to automate these, we had to remove all the ambiguity. So we made specific decisions as consistent as we could with IFPUG guidelines, but to clarify how things were to be automated and how they were to be counted so it would be cheap and consistent. And we'd have a consistent answer every time we run it on the same piece of software. That specification has been completed. It's going through the OMG process for becoming a supported specification. We believe that within the next couple of weeks, there's a very good chance it will receive final approval. In fact, we'll be discussing it at the OMG meeting next week in California. The second document, which is available to you on the CISQ website, or available to members, and membership is free, is the definition for the automated quality metrics for reliability, security, performance, efficiency, and maintainability. I'm going to give you a short description of how these measurements are formed, but that's available right now, and a number of IT organizations are writing these kinds of metrics into their outsourcing contracts as really as service level agreements, as SLAs, that they expect their outsourcers or their suppliers or vendors to achieve. And the problem that drove the creation of CISQ was that the outsourcers, the system integrators, were saying, look, we can't deal with 75 different definitions of the same metric. We need one international standard. And so that's what led SEI and OMG to jointly form CISQ. So we have completed that work. It's now available on the OMG website for people. It's publicly available for people that would like to use these kinds of metrics in their various outsourcing or other kinds of contractual arrangements, or in terms of benchmarking their own internal quality. Now let me show you what these look like. We did as good a job as we were able to define these metrics consistent with the way they're defined in the new ISO standard 25010, which replaces the old 9126. But that will be the new international standard for measuring software quality characteristics in software-intensive systems. And we've picked 4 of those areas: reliability, performance, efficiency, security, and maintainability. And we've looked at the sub-characteristics and made sure that we had some aspect of these measures that covered each of the sub-characteristics under those primary software quality characteristics. So we're doing as good a job as we can in trying to make sure these are compliant with and consistent with the international standards. But ISO standards don't carry these measures all the way defined to the level they can be used for automated measurement of source code. Here's an example of what one of those measures would look like. This is for the measure for reliability. And basically what the CISQ team did is go in and define the major issues that IT organizations face in the area of reliability. We did the same thing for security and performance and maintainability. But for instance, here's an issue. One of the quality issues is really it's a high-level description of a cause of a problem. So you can see issue number 1, inconsistent or incomplete handling of errors and exceptions leads to inaccurate identification and inadequate response to errors, which can cause all kinds of problems and potential outages, hang-ups, and a number of other issues. And so related to that, then, the CISQ team defined specific quality rules that you would want to enforce in order to avoid that problem. So rule number 1 would be that exception handling blocks such as catch and finally blocks must not be empty. And then we look in the code, we define a measure as being able to find violations of that rule. So you can look at measure number 1 and 2 are related to this empty catch block issue, number of exception handling blocks such as catch and finally that are empty. And so there's 30 different measures that are aggregated together and summed together to form the overall measure of reliability, and they cover all the sub-characteristics that we found in the ISO standard. But these are now down at the detail to where we can go into source code and measure them. So these are automated measures that can be used to evaluate the quality of source code, in this case in the area of reliability. But we also have these for the other 3 areas as well. So they're detailed. They're based off severe problems. We didn't look at every problem. If it was a minor problem, we didn't include it. The CISQ measures really just cover problems that we know we need to remove in order to significantly reduce the risk of, in this case, an outage, or in the case of the security measure, a penetration to confidential data and other kinds of security problems. So this is the work that CISQ has accomplished. That's now available on the CISQ website as a CISQ standard. We'll be moving it over into OMG and ISO processes in the next year or 2. But that is available for use because we know we have a number of companies wanting to use that in their contractual work today. So this is where we are, and we're now, CISQ membership is now free because our objective now is to begin deploying these measures across industry. And therefore, we want to make the CISQ website a major resource for people wanting information on non-functional requirements or structural quality issues, structural quality measures, So this is we're going to be developing this as an industry resource specifically in the area of structural quality, what some people would call non-functional quality. And we'll have blogs, we'll have pointers to other resources that we think are important in the measurement area. We'll have our standards as well here. Membership is free. We encourage you to join. You'll notice that over the next several months, the amount of content will grow fairly substantially as we begin building this as a community resource. So that really is where we are today. That's where CISQ has evolved, and some of the accomplishments that we've made and where we're trying to drive CISQ in the future. Really, the objective is to really improve our ability to measure the risk of software and the costs associated with trying to make software better and deal with the overall structural issues in software, because those are the ones that tend to cause the big problems, the big outages, the big security breaches, the big performance problems, and what have you. So having given that kind of overview of where CISQ are, let's get practical now. Let's talk with CIO about the real problems in industry and what she sees as some of the needs she has and some of the solutions she's seen and how she's dealing with some of these issues. So we're going to talk today with Jasmine Alexander. She's the Senior Vice President and CIO at Penton Media, which is a major company in the publishing area and trade magazines and kinds of content. She has a broad experience, which I want her to describe here in a second, but it's going to really give us a very deep vision into some of these issues in the area of broadcasting and print media, and we'll see how those generalize to other kinds of areas, but we'll get a very deep dive into some very interesting kinds of problems that she's faced in her career. So Jasmine, why don't I let you introduce yourself to the audience and kind of briefly go over your background and the kind of experiences that have led you to the point you are today.
Hi, good morning, everyone. I am currently the CIO of Penton Media. I'm responsible for both IT and product development. I've been in media most of my career. I took a couple of positions doing e-commerce, which is related, and also in publishing, broadcasting, cable, interactive TV, all of those different media segments. They'll ask me to speak about some of the mission-critical systems in media. Of course, you are all familiar with websites. All of the websites are pretty mission-critical because if the pages don't serve quickly, people leave. Also, ads need to be served. Some of the websites are subscription-based, so people need to be able to access content. Ad servers, which are very critical to getting the ads served in the right places. Scheduling and trafficking systems, and this includes everything from the TV guides that shows up on your set-top box to commercials that you hear on the radio or even ads that you see on the internet. Connectivity to satellite and broadcasting systems, because these schedules then the commercials then need to be aired at the right time on the right channels. And quoting and inventory management, which is very similar to airline and management, which is basically perishable inventory.
Jasmine, how have you seen the responsibilities of IT and therefore the CIO's responsibilities evolve over the course of your years in IT?
Two things, Bill. One is, you still have the legacy vertical systems, primarily business related, and then you have huge advances in technology. For example, when I was at ABC Radio, we were just getting started with internet audio, and the quality was absolutely horrific. Now you expect 64-bit quality pretty much anytime you hear a podcast or even a webinar.
Okay. What are the key business processes running on software across the various media areas you've been involved in?
Well, primarily about sales and inventory management. I mean, of course, that's where the revenue drivers are. So managing your sales, pricing properly, because it's a supply and demand situation in most broadcasting and media publishing included operations. Definitely on the website. Some websites are sold out months in advance, so you want to be able to be flexible with your pricing. So managing inventory is absolutely critical. The other areas are content management systems, where our editors who are around the country, around the globe, they may be attending a trade show, log in and produce content that then immediately appear on a website or subsequently into a print magazine.
Where do you see most of the customization happening, and what kinds of things are driving it?
Again, I want to say it's the advances in technology. It's both from a standpoint of the storage, which has gotten to be cost almost next to nothing. Also bandwidth. Bandwidth is widely available today. Even 10 years ago, that was not the case. And just advances in mobile technology. A smartphone today is more capable than a computer was 10 years ago. Not even 10 years ago, even 2 years ago. So the advanced location services is driving a lot of innovation in not just the media, but also related technologies, related industries such as social media, email, texting. So new products are being developed by startups that are challenging the established media.
Okay. Well, your future focus and the most strategic parts of your investment?
We see a lot of investment in mobile. We have, mobile-friendly websites. All of our content management system automatically produces a mobile-friendly website. But also we are developing apps, mobile apps. We have tablet apps that are just catered to the B2B business. For example, our Trust in Estates brand has an app that's sold on the App Store for about $199 per year. It is a very specific B2B application geared towards financial planners and estate planners. We are working on several other applications based on our B2B data that we provide to individual companies, but also to insurance companies, such as prices on tractors, large-scale trailers, that sort of thing. So we're working on apps that people can actually, when they're at an auction or when they're looking at a piece of equipment, use an app to get all of the data related to that type of equipment. So that's
I remember many years ago, Colin Crook, the former CIO of Citibank, once saying that Citi was a large software development house masquerading as a bank, because everything was being put on computer systems. And it sounds like, from what you're saying, the same kind of thing is happening in the media industry. It really is becoming a very large software. About that?
Yes, actually, as you know, we collect a lot of data on equipment pricing, et cetera. And what we are doing is we're actually now developing APIs that our partners and customers can use to get data from us with an FTP file or some other mechanism. So we are developing APIs for basically transitioning into a company in some areas of our business, so that we can more widely distribute the information that we collect. So that's like the other part of it is that we're also using it into our databases.
Well, since you're getting more and more into providing these kinds of services and understanding the functional requirements for these things, because we can write those down, you give us some ideas about how you manage what kind of non-functional requirements are important and how you're dealing with those?
Yeah, absolutely. Speed and availability are probably the two biggest ones. And if anybody has worked on API, that you can have is that it makes the database unavailable, if you will. So our biggest challenges are trying to throttle the data coming in and make sure that the requests are well formed as they're coming in, so that we don't actually query the database before we verify that the requests are well formed. So that is one area. The other area is clearly speed, because you don't want the API hanging in the middle of a query.
Well, some of those concerns sound like the same kinds of worries people have in the security world about the formation of queries that come in and whether that allows them to sneak into the database and get things they weren't supposed to get. And I know there's been debate that over whether security is a quality issue or whether security is something completely different from some of these other non-functional requirements. Do you have any kind of vision on that, or how are you thinking about that at Penton?
We authenticate the requester, whether it's from an IP, a username, password. So we're limiting access to specific installations where we get requests from. As we add their